Welcome to the deep dive. Today we have just a fascinating stack of your source materials. We're talking articles, statistical reports, regulatory summaries, and we're doing a targeted deep dive into electrical worker safety. Specifically, how this inherently lethal field has evolved over 2 decades, from 2005 to 2025.
It really is a remarkable story of transformation. And to get how far we've come, you have to look at the starting line. Your sources confirm that back in the 80s and 90s, electrical fatalities made up a shocking 8% of all workplace deaths.
8%. Wow, that's a huge slice of the total risk pie. And the peak was right at the beginning of our analysis window, wasn't it? 2004 had 254 fatalities, and 2005, that was the highest for non-fatal injuries. It was, what, 2,950 incidents?
That's right. Incidents that required time away from work. It was a high-risk environment, high exposure, and frankly, just not enough protection.
So our mission in this deep dive is to trace the precise things that drove safety from those staggering peaks to the relatively improved conditions we see today.
Exactly. We'll show you how regulatory pressure, economic forces, and new tech all kind of converge to rewrite the safety standards for the next generation.
Okay, let's unpack this. Let's start with that initial period, that high-risk environment leading up to 2010. What were the actual risk drivers behind those, 250-plus annual deaths?
Fundamentally, it was a cultural and systematic failure. The source documents really highlight a lack of standardized personal protective equipment, PPE, across different industries.
Mm-hmm.
And that was paired with just inadequate training. So while safety standards like NFPA 70E had been around since 1979, they weren't really driving the cultural shift you needed, a shift toward prevention, not just compliance.
So the standards were on the books, but not necessarily in the field, or at least not enforced across the board.
Pretty much. And we see that first big drop-off in fatalities starting around 2005. They went from that 200-250 range down to about 160-180 by 2010.
Right.
Yes. And this is where it gets really interesting, because that first wave of success wasn't purely from regulation. The data points to a major external factor.
You're talking about the economic downturn, the Great Recession. The sources are pretty clear that some of this drop in risk was, almost accidental.
Precisely. The BLS data confirms it. The decline in fatal electrical injuries actually picked up speed after 2006. And why? Because the massive slowdown in construction and manufacturing meant fewer workers were exposed to high-risk tasks. It's simple, really. If you stop building, you stop exposing people to live wires.
Hold on. So a big part of this early safety success was just a bad economy, not better rules. How did the industry square that circle in its analysis?
Well, they couldn't ignore the numbers. The recession acted like a forced pause. It cut the sheer volume of high-risk work, which bought regulators critical time. So while the economy gave us that initial drop, the regulations that were coming into effect, like the 2004 edition of NFPA 70E starting to focus on arc flash hazards, that set the stage for sustained improvement later on.
Okay, so it was a confluence of the two. The pause let the new standards take hold. Speaking of sustained efforts, let's jump forward to the next decade where that systematic work really starts showing up in the data, even as the economy recovered.
Right. By 2020, we hit a remarkable low, 126 fatalities. That's a 24% decrease from 2019 alone. And the long view is impressive. Electrical incidents fell from 8% of all workplace deaths in the 80s to just 3% by 2020. That's real, measurable progress.
But the data also provides this huge aha moment, especially for anyone managing a job site. And that leads us to the surprising fact buried in the stats about who is actually getting hurt.
What's fascinating here is, it's the breakdown of who is still exposed and, sadly, who is dying. When we look at the fatality data from, say, 2011 to 2023, the highly specialized roles.
The electricians, the power installers.
Exactly. They certainly carry high risk. Electricians had 212 fatalities, power installers 122. But they're not the majority of the problem.
You're saying the risk is concentrated outside that highly trained specialist core?
That's it. Non-electrical roles account for a massive 74% of electrical exposure deaths over that period. And this is the key insight for you, the learner. Think about who these people are. Construction laborers, tree trimmers, equipment operators. They're the non-specialists working around power, but maybe without that daily intensive electrical training.
Wow. I always assumed the risk was with the specialists. That 74% figure it completely changes how a manager needs to think about site risk, doesn't it? It's not just about the arc flash gear for the electrician, it's making sure the tree trimmer knows exactly where the power lines are.
Or that the laborer digging a trench understands the utility markings. It means the solution isn't just better training for electricians, it's mandatory general awareness and enforcement for everyone else on site.
A huge shift in focus. Now, what about the injury data? Non-fatal incidents peaked in 2005. They dropped a lot, over 40% by 2016. That suggests the early changes worked well for day-to-day incidents.
They did. But the data also reveals the pressure points. We saw this worrying 35% spike in non-fatal incidents in 2017. If we connect this to the bigger picture, that spike probably correlates directly with the post-recession construction boom. More workers back on sites quickly, maybe without the same level of consistent training.
And the injuries stabilized after that.
Yeah, around 1,500 to 2,000 annually.
And the most common injury is burns, right? About 39% of those incidents. Burns are the painful, visible sign of a failure-bad PPE or a failed procedure.
It's also really important to note the demographic disparities in the sources. Hispanic and Latino workers face higher fatality rates that have actually increased over time, often in that same high-risk construction sector. It suggests that things like language barriers or temporary contract work are still contributing disproportionately to who carries the risk.
On the positive side, though, we can tie the overall injury reduction to some tangible factors. The source material notes that unionization correlates with much lower fatality rates for electricians.
Which isn't just a footnote. It suggests that highly structured, pure enforced safety cultures are just dramatically more effective.
Right. And early tech helped, too. Better tools, improved isolation techniques. This shows that, organizational structure and proactive investment were just as key as the regulations themselves.
The whole journey was underpinned by that strategic regulatory muscle.
Let's talk about that, the evolution of the standards, because that's what really mandated the cultural shift we've been discussing.
The single biggest systematic change was, you could argue, the 2012 edition of NFPA 70E. This revision was philosophical. It moved safety from a checklist of compliance to a mandate for proactive prevention. It did that by introducing the mandatory concept of a documented risk assessment.
Okay, so explain the difference for our listeners. What does that actually look like on the job? Compliance versus risk assessment.
Well, pre-2012, a standard might just say, for this work, wear Category 2 PPE, generic. Post-2012, that's not enough. The new rule said you must perform an engineering calculation, an arc flash analysis, to find out the potential energy for that specific task on that specific piece of equipment. Then you pick your gear based on the actual calculated hazard, not some generic rule. It forced companies to analyze their processes minute by minute.
That level of detail requires active oversight, and the sources show that enforcement agencies stepped up their game. OSHA increased citations for things like lockout-tagout failures and PTE compliance.
They had to. And that regulatory pace hasn't slowed down. Between 2021 and 2025, we've seen even more guidance. In 2024, OSHA released a major update on electrical safety, the first big one in over 20 years. It really embedded that risk assessment philosophy even deeper into the federal guidelines.
And 2025 brought more action with revisions to the Hazard Communication Standard, the HCS, which is important because it changes how people see new hazards.
That's right. The HCS updates mean clearer, standardized labeling for electrical risks. That's vital, especially with new energy storage systems. Plus, they increased penalties and added specific PPE rules for the construction sector, that 74% vulnerability group we talked about.
So if we connect this to the bigger picture, the regulation drove consistent, if maybe frustratingly slow, progress. The combination of mandatory calculation-based risk assessment and persistent enforcement is what brought us from 254 fatalities down to the estimated 140 to 150 we see today.
It's a huge improvement, but as that number shows, the journey to zero isn't over. The risks have just changed. They've gotten more complex.
Let's pivot then and look ahead. If the last 20 years were about standardized PPE and risk assessment, what defines the future? What does the 2030 electrician look like?
I think the defining trait will be technological integration. Moving beyond passive protection to predictive interaction. We're already seeing wearables, but by 2030, the vision is widespread use of smart helmets, smart gloves, smart vests.
And how do these smart devices actually prevent an injury?
They're essentially real-time monitoring systems. A smart vest can track heat exposure and worker fatigue. Gloves can have sensors that warn you if you're getting too close to an energized conductor. It moves safety from post-incident analysis to moment-to-moment prediction.
Which cuts down on human error risks significantly.
Absolutely. And you pair this with the rise of automation. AI-driven predictive maintenance will identify failing equipment before it becomes a hazard. Drones and robots will handle inspections and high-voltage repairs, minimizing human exposure entirely.
But new tech always brings new hazards, right? And the sources point to massive industry shifts that will reshape the risk profile.
The electrification boom is the biggest one. The rapid growth of renewables, solar, wind, EV infrastructure, it all introduces new dangers, the most prominent being high-capacity battery systems. Battery fires, for example, require completely different suppression techniques than a traditional electrical fire. There are unique chemical hazards. Standards are really struggling to keep up.
And the skill gap must be immense. A traditional electrician is now facing complex digital and chemical problems.
That's right. With smart homes and smart cities, the sources suggest even installation work now requires specialized cybersecurity training. The infrastructure is digital. A bad install could open a digital vulnerability. We're also seeing a bigger focus on psychological safety and the use of advanced VR training to simulate high-voltage scenarios safely.
So the forecast is complex, cautiously optimistic, I guess. The sources suggest fatality rates could drop another 20 to 30% by 2030, but that progress is contingent on a few things.
It is. It depends entirely on whether the industry can close those skill gaps training workers on renewables and cybersecurity and manage supply chain risks. If new equipment is sourced without rigorous safety checks, all this progress we've made could just stagnate.
So what does this all mean? We've traced this remarkable two-decade journey from nearly 3,000 injuries a year to a world that's on the cusp of AI-driven prevention and smart gear. This transformation wasn't one thing. It was driven by these sustained philosophical shifts like mandatory risk assessment from NFPA 70E, consistent OSHA enforcement, and, targeted tech adoption.
And we're at a critical inflection point. The source material basically lays out two paths forward. There's the optimistic vision of near-zero fatality sites, driven by AI and automation. Or there's the pessimistic vision, where progress stalls because our regulations and our training just can't keep up with all the new tech hazards, especially in things like battery storage.
And as we close this deep dive, here's a final thought to consider. The central lesson from the last 20 years is that the biggest risk is often outside of specialized training. That 74% fatality figure for non-electrical workers proves it. So if complex risk assessment is now standard on commercial job sites, what new hazards are emerging in your own non-specialist everyday environment? Whether that's managing complex remote work electronics, installing solar, or dealing with a smart home? What requires you to apply that same professional mindset, even if you don't wear a hard hat?
Something to mull over as you assess the risks right around you.